very positively highlighting the opportunities to match supply and demand. Our next speaker is Dr. Rory Monaghan from NUI Galway. Rory's a lecturer in energy engineering here and is going to follow on from Paul to give us some case studies and some good examples. Thank you.
Thank you. Thanks very much. So I'm going to be talking about my work as part of the GenCom project that Paul gave an overview to. So my work within GenCom is developing or giving the final deliverables of the project, which are a decision support tool that we're calling Smart H2GO, and a network of potentially interested hydrogen stakeholders called the Community Hydrogen Forum. So I'm going to describe what Smart H2GO is. Since you've been good enough to come here to Galway, I'm going to use it to conduct a sort of a thought experiment for Galway if we were to use some curtailed wind from Ireland's largest wind farm, which is located just outside the city here. And give you some information on the Community Hydrogen Forum and what some next steps are if you're interested in engaging with that. And that doesn't work. Okay. All right. So just to recap on what Paul said about GenCom, the main deliverables of GenCom are the decision support tool, Smart H2GO, and the Community Hydrogen Forum. And what these two deliverables are kind of linked. We have an issue with hydrogen that's been described by a few people as being the chicken and egg problem, that without demand for hydrogen, it's hard to build up a supply infrastructure, but without supply infrastructure, you won't get people to demand it. So the decision support tool is an attempt to link those two kind of disparate groups together to and link up different suppliers potentially as well. And we're doing this essentially through information. Then from that, what are the next steps? If people are interested in getting into hydrogen, and they're not familiar with it, what are the next steps for them? And that's where the Community Hydrogen Forum comes in. So I'm going to show a case study. So I just want to kind of frame the case study first before I dive into telling you what the decision support tool is all about. But the framing of the case study is, can we use, I'm just using the term wasted wind energy. What I'm really talking about here is curtailed and constrained energy. So this is energy that doesn't make it to the grid, that has the potential to be generated, but doesn't make it onto the grid. Can we use that from the 174 megawatt Galway wind park to fuel Galway's bus network? And the little map in the bottom there, that's just showing it's approximately 35 kilometres from the centre of Galway here at the docks up to the Galway wind park. If you have spare time on your visit to Galway, it's absolutely beautiful up there. And I see the park manager is at the very back there, John O'Sullivan, and he's always more than happy to give people a tour of the farm. So how does the kind of a general overview of what we're trying to achieve with the decision support tool? Well, we come at it from a kind of a bottom-up approach. For this case, we're looking at buses. So we're going to look at what's the annual hydrogen demand for a bus. We'll look at that briefly. A lot of people in the room will have a figure for that. We can work out a total demand. Then we need to work out what the total potential supply of hydrogen is. And we do that by looking at the statistics of curtailed wind that we have. We've made some tools that can help us sort of aggregate that over a large number of wind farms. And we can come up with optimized electrolyzer sizes if we're looking primarily at using curtailed energy. And we can come up with a total hydrogen supply. We can then use mapping software. We use GIS software to develop the supply chain. And we have a submodel that deals with the transportation aspects of hydrogen as well. So everything that we're going to talk about today and the decision support tool to date, we're about 2 years into a 3-year project at this point. So this is all still work in progress. Everything that we're looking at to date deals with onshore wind and deals with urban bus fleets to date. And the supply chain, the hydrogen supply chain, is all assumed to be high pressure tube trailers. Okay, so how it works slightly on a more technical level. We've got input. Well, the colors don't look so great there, apologies. got input, we've got a technical model, we have an economics model, we have some techno-economic inputs, and we have a transport model. And this is going to give us a levelized cost of hydrogen. So the specific inputs that we need for any user of the tool, what we look for is the percentage of wind that is curtailed. Okay, we're using the DD term here, the dispatch down term, but the wind curtailment percentage, the capacity factor of the wind farm, and the overall capacity in megawatts of the wind farm. With that information, we can move to the sizing of the electrolyzer. Now, I'm not going to go into all the details of that here, but I'd be very happy to bore people to death with how we do that. But we can size an electrolyzer. We use the term optimum here. We think it's a pretty good way of sizing it. We try and trade off the need to maximize it, to capture more of that curtailed energy, but also keep the size of it down so it's not sitting idle in these periods where the wind isn't being constrained. And then we can require, we can examine then how much water is required and how much additional electricity from the grid is needed to maintain baseline operation of the electrolyzer, and also if we want to top up the running of the electrolyzer with grid electricity. We can calculate with our economic parameters that we get. This is the nice thing about being in GenCom. We've got a huge network of partners here who are hydrogen technology suppliers. So we think we've got some good numbers on the techno-economics of hydrogen. We can come up with our economic figures and get our levelized cost of hydrogen, LCOH. We can then, using our GIS, linking between supply side and demand side, we can get the LCOH, including transport. Okay, I won't dwell on that. So just a note on the demand. Galway, I was surprised to see it was so few. 36 state-operated buses, so Bus Éireann is the state bus company. They operate 36 buses in the city. City Direct, which is a private operator, operates an additional 20. So this is like literature figures on diesel consumption rates. These may not apply exactly to Galway, but this is our thought experiment here. So total diesel demand for the network of about 2 million litres a year for the Galway bus network. If we were to convert these buses to hydrogen using state-of-the-art commercially available hydrogen buses manufactured in Northern Ireland by Wrightbus, we're looking at a total hydrogen demand, if we were to switch over the whole network, to about 400 tons per year. Yeah, 400 tons per year. Now, this is just showing our, this was something that Paul showed already. This is our dispatch down volumes available throughout Ireland on the left-hand side, and our dispatch down percentages across Ireland. So we're between about 5 and 6% of the wind energy that we generate in Ireland never makes it to the grid. And the projections are showing that could stay constant over the next 5 years, or it could double, triple, possibly, or over the next 5 years. So the scenarios that we're going to look at in the results that I show you, we're going to see 3 sets of results for the decision support tool. One set of results is when we only used curtailed electricity to produce our hydrogen. This has got the advantage of, it's totally green, indisputably green electricity, or green electricity, therefore green hydrogen. It's got no impact on the wind farm output, and we can use, since the electricity is all curtailed, the electricity is very, very low cost. Its disadvantages, we're going to see that this has got an extremely low capacity factor for the electrolyzer. The electrolyzer is essentially sitting idle the majority of the time. Second scenario then is we use curtailed electricity plus output from the wind farm to keep its capacity factor up. So it's still green electricity, green hydrogen, still low capacity factor, and it does now have an impact on the output of the wind farm. Oops, and let me go back. And then the final scenario is if we use curtailed electricity, used output, and also purchase grid electricity to keep the electrolyzer running at its maximum. We've got a nice high capacity factor, but we now have a mix of green and grey hydrogen. And this is really where some of the other EU-funded projects on certification methods for renewable hydrogen start to become very important, because our electricity source is now mixed. How can we separate out the green from the grey hydrogen in that case? So in all of these cases, we're using a high and a low electricity price. The low, a price that our electrolyzer system will pay for electricity, 0 cents in the low case and 8 cents in the high case. So we'll be just bounding our problem here. So first of all, let's look at production, just raw production at the moment. So the red line is what our hydrogen demand for buses in Galway is currently. This is our 390 tonnes per year. So if we're only capturing curtailed electricity using what we view as an optimally sized electrolyzer, which is slightly over 20 megawatts, we are producing significant excess to what's needed to run the Galway bus network. If we were trying to get the electrolyzer capacity factor up by using the additional energy from the farm and get it up further from additional energy to the grid, you can see that there's huge overcapacity there. So this wind farm has got the capacity to deliver a lot of hydrogen, more than what the Galway public transport system needs. So if we were to, if we were to say, well, okay, we don't want to oversize this electrolyzer, let's just size the electrolyzer for each of these cases such that we're producing what the bus system needs. You can see we need much smaller electrolyzers. So for curtailed only, an 8 megawatt electrolyzer. For using the curtailed and the wind farm's output, 3.5 megawatts. And for using the grid-supplied electricity as well as the wind farm output, 2.5 megawatts. And this is because it's smaller here because we've got a more constant supply. It needs to be bigger here because we have to absorb some of the peaks of curtailed output that are available. In terms of costs then, and I'm conscious of time at the moment, so in terms of our costs, this is our projections for levelized cost of hydrogen production and delivery to the bus fueling depot in Galway docks. So for curtailed only, we see the highest costs in the range of about 16 to 21 euros per kilogram. And again, recall that this is to do with the low capacity factor of the electrolyzer. You'll see that the range here this is the 0 cents electricity and this is the 8 cents per kilowatt hour electricity. So there is obviously an effect of the cost of electricity, but it's not the dominating factor here. This is where we use output from curtailment and the wind farm itself, and then we get our lowest cost of around 13 to 16 euros per kilogram when we maximize the operation run hours of the electrolyzer. In terms then of, so that was hydrogen production. In terms then of how much it costs to operate a bus, if you're a bus operator, you don't particularly care about how much the hydrogen costs, you're interested in operating costs. Well, this is the operating cost expressed per kilometre for a diesel bus, and then for our 3 hydrogen supply options. So you'll see that we're starting off at about 65% higher than diesel operating costs, coming down to about 55% above diesel operating costs. So some conclusions of this. Well, I've gone through these. I've gone through these before. We're starting off with if we use curtailed electricity only, we're in the 16 to 21 euro per kg range for providing hydrogen to the bus filling station. If we run the electrolyzer 24/7, essentially, we're getting it down to about 13 to 16 kg, but we're still above the operating cost of a diesel bus. Now, in terms of next steps, if what you've seen is interesting, and if you're outside of the hydrogen industry and looking to learn more about it, as part of GenCom, we'll be setting up the Community Hydrogen Forum, which will be, in the first instance, for stakeholders across Northwest Europe, because that's the GenCom funding area that we're in, but we intend to open this up to people across Europe. It will be launched in Dublin on the 21st of October. please contact me if you're interested in coming along to this. It'll be a totally open event, and we'll hopefully get to. There'll be an online version of what I've displayed here, and hopefully you'll learn something and you'll be able to tell us what you're interested in doing. So thanks very much.